All right, guys, welcome back. This is going to be our last clips from Unit 8A. Last video was spent on simplifying trig expressions, so now we're going to be verifying trig expressions, which could be seen as more difficult, could be seen as easier, depending on, how your brain works and how you're doing with this so far. I will say that basically what's going to happen is they're giving you a trig expression and they're going to give you what it's equal to, and you have to prove that it is equal to that by following, certain steps and figuring that out. I will say that there are many different ways. Again, we've talked about this. There's many different ways to solve these. Or there can be. All right, many different ways to prove expressions, and I'm going to do 3 examples here. One thing I want to talk about that I have out is all of my reciprocal, like my identities. Okay, I've got my reciprocal identities here, quotient identities, and then the Pythagorean identities. And these are the same, like these are the original Pythagorean identities just written several different ways. And you'll want to make sure that you have this. You're going to want to make sure that you have these written down. So if you have your trig expression sheet, that's great. But if not, pause this and write these down because you're going to need them. All right, I've written a couple of steps that are going to be helpful. Again, there's many different ways to do this. There's not a black and white, like step-by-step approach that you can take to get the correct answer. But I will say, typically you want to use the Pythagorean identities first and then use quotient and reciprocal identities. One thing you need to know about the quotient and the reciprocal identities is that they can work if they are squared too. For example, you have cotangent x is equal to cosine x over sine x. That is also true for cotangent squared x is equal to cosine squared x over sine squared x. And it's the same for all the reciprocals as well. You would have sine squared x is equal to 1 over cosecant squared x, because 1 squared is just 1, so that doesn't change. So reciprocals can work normally or squared, and same with the quotients. All right. We're going to show you a couple of specific types of cases down here that are going to need a couple of extra steps, but we're going to work through them one by one. So the first one we're going to do is to verify that cosecant squared x minus 1 over cosecant squared x is equal to cosine squared x. One thing I've read is that it's good to put everything in terms of sine and cosine when possible. For example, here, they're not equal to cosine and sine, so you're actually taking that and working it backwards, but a lot of times it's going to be very beneficial to find a way to do that. So for this one, again, the first thing I'm going to look for is Pythagorean identity. So the first one I see is cosecant squared x minus 1. I'm going to look to my chart here and find that cosecant squared x minus 1 is also equal to cotangent squared x. So I'm going to go ahead and rewrite it as cotangent squared x over cosecant squared x is equal to cosine squared x. All right, now we have to find a way to convert both of these, cotangent squared x and cosecant squared x, into something with cosine in it. Okay, so I'm going to look at cotangent squared x and see if there's any way I can convert this to cosine. Now, I see that cotangent x here is equal to cosine over sine. And again, that is true for squared ones as well. So I'm actually going to convert cotangent squared x to cosine squared x over sine squared x. All right, and then I've got cosecant squared x. If I'm going to convert that to anything sine or cosine, I can convert it here to 1 over sine squared x, and that's what I'm going to do. Now, a little trick for these is when the denominators are the same, because you end up flipping the second one and multiplying, that would put sine squared on top. They cancel out. So when you have a fraction over a fraction and the denominators are the same, you can just cancel them out. So we end up with cosine squared x over 1, and yes, that is equal to cosine squared x. All right, moving on to our second one. I'm gonna move this cord out of the way a little bit. Okay, we are going to verify that sine x over 1 minus cosine x is equal to cosecant x plus cotangent x. All right, so the first thing I am going to do, we are going to have to get rid of this denominator somehow. There is no way that we can use this for Pythagorean identities because there's nothing squared, and Pythagorean identities do not work unless they're squared. So it's not like the reciprocal and quotients where you can use them singular or use them squared. Pythagorean identities only work as they are. All right, so first thing I'm going to do is try to change this to where it is a Pythagorean identity. Now, the only way I could do that is to somehow multiply it by cosine. I can't just multiply it exactly by cosine, because then if we were to multiply this by cosine, it'd be cosine minus cosine squared x, and we're not gonna be able to do anything with that. So I'm actually going to multiply by a conjugate of the denominator. We've done this in a few different ways. And what that means is I'm going to take sine x over 1 minus cosine x. I'm going to multiply the top and the bottom by 1 plus cosine x. Because whatever I do to the bottom, I have to do to the top. And we're not doing it across the equal sign because whatever's on this side doesn't exist yet. We're trying to prove that that is, in fact, what it is. So I'm going to multiply the top and the bottom by 1 plus cosine x. Once we do that, I'm going to leave the top separate. Sine x, 1 plus cosine x over, we have 1 times 1, then it would be plus cosine x minus cosine x, right? We're factoring it out, multiplying, and then minus cosine squared x. And here we'll be able to convert this into a Pythagorean identity. So we have 1 minus cosine squared x. We're going to change that to, let's see, 1 minus cosine squared x is sine squared x. So then we have sine x over 1 plus cosine x over sine squared x. Okay, we can cancel out the sign on top with one of the signs below. So I'm just going to rewrite it as just sine x because the squared goes away. All right, so I'm just going to go ahead and rewrite that as 1 plus cosine x over sine x. All right, I have to find a way to make this equal to cosecant x and cotangent x somehow. So let's see if there's any way we can convert these. What is cosecant x even equal to? Well, I know that cosecant x is equal to 1 over sine. Okay, we have a 1 over sine here. And then cotangent x is equal to cosine over sine. Well, we have cosine over sine. So let's separate this. Anything over one denominator, we can separate it apart. So I'm going to have 1 over sine x plus cosine x over sine x. And that gives us exactly what we want. 1 over sine x is equal to cosecant x plus cosine x over sine x, which is cotangent x, is equal to exactly cosecant x plus cotangent x. All right, a lot of it is going to have to do with what's on the other side of that equal sign. What am I trying to get it to look like? And that's going to lead you to look at certain identities that are going to help you figure that out. So let's move on to our third one. We are verifying that tangent squared x over 1 plus secant x is equal to secant x minus 1. So at some point, we're going to have to get rid of our denominator here as well. We're going to end up working this one a little bit backwards than what we did on number 2. So let's see, what's the first thing I can do? What I'm actually going to do is change tangent squared x. We use Pythagorean identities first. Tangent squared x is equal to secant squared x minus 1, which is good. That's going to help us cancel things out eventually. So we'll write secant squared x minus 1 over 1 plus secant x. Now, the only way I'm going to be able to cancel out this denominator is if I somehow have a 1 plus secant x on the top. Well, this is exactly what we did over here, except it's the reverse, because 1 minus cosine squared x is the same thing. I mean, it's very similar here. What we did was separate it into a 1 plus cosine, 1 minus cosine x. We can do the same thing up here with the secant. All right, so what I'm going to do is break it down into secant x plus 1 and secant x minus 1. All right, and you can think of that the same as like x squared minus 1. This is equal to x plus 1, x minus 1, and we've done the same thing here, x plus 1, x minus 1. All right, and that's all over 1 plus secant x. Well, we can already cancel something out. We're going to go ahead and cancel these things out. And that's our answer. We are left with secant x minus 1, which is equal to secant x minus 1. All right.